This is section 8.4, number 20. This problem's a little bit tricky if you've never seen one like it, and you're going to see a lot of these, on standardized tests and things like that. So I thought it'd be a good one to look at. Looking at this picture, what I see is I have similar triangles. I got this triangle and this triangle are similar. They share this angle here. They both are perpendicular to the ground, so they both make right angles with the ground. So that's what I have. I have angle-angle similarity, proving that those two triangles are similar. Well, that means that if I set up the proportion, this side corresponds to this whole side, 3 plus x. And then this side, the height of shad, 5.5, corresponds to the height of the lamppost, 12. So if I look at the corresponding parts and I want to set up a proportion, x over 3 plus x equals 5.5 over 12. And now here's the problem I need to solve. So let's cross multiply, divide, I get 5.5. Distribute the 5.5 to each part. 5.5 times 3 is 16.5. 5.5 times x is 5.5x equals 12x. I'll subtract 5.5x. I get 16.5 equals 12 minus 5.5, which is 6.5, I believe. 6.5x. So now you divide both sides by 6.5, and I get a decimal, so 2.54. So if you were wondering about this question, you're like, I got a really weird answer. Yeah, your answer should be weird. It's 2.54. And again, it's in feet. So that's the length of shad's shadow. Again, it tells you a bunch of information, gives you a picture, but basically it's just two similar triangles in that picture. So that was number 20 from 8.4. We're going to go right on to 23 from 8.4. If you've taken a look at 23, it's a pretty tricky question, but it uses some of the concepts that we've done pretty nicely. And what basically you know about this picture is that these parts are 4 and 5. I know this is 4. I'm going to put that in a second. I'm just going to look at what I know, and I know that these two triangles would be similar by angle-angle similarity. They have vertical angles. They have alternate interior angles. All right, they're similar by angle-angle similarity. So I'm going to say the proportion that I could set up there, which is EM over MJ. And you're like, well, why are you doing this? And that's the big question, and that's kind of why I'm showing you this, because it is a tricky problem. I think originally when I looked at this question, I had trouble with it. So if you're having trouble with it, it's nothing to be ashamed of. But that is one of the proportions you could set up for those triangles. I also have, because this is a parallelogram, these sides are parallel, I have this triangle is similar to this big triangle here. And it's because you have alternate interior, you have vertical, but angle-angle similarity again. And when I set up the proportion, I use some of the same sides. So if I ignore these blue triangles for a second, just gonna pull those out there. Just get rid of them. So when I look at these blue triangles for a second, I see EM corresponds to MH, just as KM corresponds to MF. Okay, so EM over MH equals KM over MF. So these are my two proportions. And looking at these proportions side by side, it looks like I got the same ratio here and here, MF and KM. Okay, so what I can do with this is I could just flip these things over and it won't change anything. So I'm going to change this proportion from EM over MH to MH over EM. Oops, MH over EM. Equals MF over KM. And what you see here is comparing that with this one, you see that both of these have MF and KM in common. So looking at this, MF and KM is in common. So by the transitive property, I can say that these two things are equal to each other. So let's say that. So that means, I'm going to put these in the picture now. So that means that EM over MJ, and my writing's all weird because the smart board went out, so I'm writing with the mouse right now, equals MH over EM. Well, the question is, what is EM? And I actually know MJ and MH. MJ is right here. MJ is 4. So I could basically just replace MJ with 4. And I know MH as well. MH is this whole segment here. That's 4 plus 5, which is 9. So I can replace that with 9. Okay, so this is a proportion I got. You end up with EM squared, EM times EM when you cross multiply. So I get EM squared equals 36. So if I can write that. And then I end up with EM equals square root of 36, which is just 6. So kind of a complicated problem if you weren't sure what to do. That's how you do it. And sorry, at the end kind of was goofy because the smart board turned off on me. But hopefully that helps. That was problems 20 and 23 from 8.4.